So this is the new chapter from chemistry, general principles and processes of isolations of elements, and we are going to discuss is the introduction part, okay, from this chapter. Now we know that some elements, right, like carbon, sulfur, gold or noble gaseous, so they usually exist in free state, and some other elements they exist in either in combined state, either in oxide, sulfide, carbonate, halide and silicate form. Okay, now the question is why the reactivity of these elements are different, okay, and because of that their existence in nature are different, and because of the difference in the reactivity of this metal, the extraction process or the isolation of the element are different. So now what is extraction process? So it is the process of obtaining crude element from their combined state, and isolation, it involves purification of these crude element obtained to get pure element. Now before moving into the main topics, so we should know some important terms. Okay, so first we'll discuss what mineral is. So you know that so the combined state of element, right? So they usually occurred on earth crust, okay, which are obtained by mining. So example, your bauxite, kaolinite, so these are the minerals of your aluminium. Now so from all the minerals of aluminium or from all the minerals of iron, so we cannot extract metal profitably. Okay, why? And those, because the percentage compositions of metal will be different in different minerals. So the minerals from where the metal is conveniently and economically extracted is what called ores. Okay, like aluminium, the ores, or from where your aluminium extracted is bauxite or kaolinite. Iron, okay, is hematite, is extracted from hematite. Magnetite, zinc is extracted from ore zinc blend, and copper from copper pyrites, by mercury from cinnabar, etc. Now what we can say is, like, all ores, okay, all ores are minerals, but all minerals are not ore, because from all minerals we cannot extract metal profitably and conveniently. Next is your gangue. So whenever your ore is collected from the earth crust, okay, so it usually consists, or it composed of undesired materials or impurities. That undesired impurities is what called gangue, like humus, sand, rock, silica, etc. Again, flux, so it is the substance which is added to the ore, okay, to convert your non-fusible gangue to fusible compound called slag is called flux. So now your flux is of two types, acidic flux and basic flux. Now acidic flux is used when your gangue is basic in nature. So if your gangue is calcium oxide, manganese oxide or iron oxide, so these all are metallic oxide, basic oxide, right? So in order to remove this, or in order to convert this to fusible mass, so acidic flux is used, like silica, borax. Okay, these two are acidic in nature. Now next is basic flux. So this basic flux is used when your gangue is acidic, like silica, phosphorus pentox. So that time we use basic flux like calcium carbonate and hematite, iron oxide. Okay, now what is slag? Slag is whenever you combine your gangue, right, which is infusible, and flux, you will get is fusible mass called slag. For example, your flux, okay, when your gangue is calcium oxide, so in order to remove this infusible gangue, okay, flux is acidic flux is used, and it will form a fusible compound called slag, which can easily be removed. Okay, so here calcium silicate is your slag, calcium oxide is your gangue, and silica is the flux. Now your occurrence of metal. Aluminium is the most abundant or third most abundant element on earth crust. So it is the major component of many igneous mineral, including mica, clays, okay, and many gemstone are impure form of alumina, Al2O3, and your impurity ranges from chromium to cobalt. When your impurity is chromium, you get is a ruby, and when the impurity is cobalt, it is a sapphire form. Now iron, so this is second most abundant metal in the earth crust, okay, and it forms variety of compounds, so which have a variety of uses. Now, so iron is also one of the essential element in the biological system. So now next we are going to discuss metallurgy. Okay, now what is it? So it is usually the extraction, the process of the metal, okay, from its ore is the metallurgy, or how can we define it is the entire scientific technological process, okay, used for the isolation of metal from its ore. Now your metallurgy process depends on the reactivity of the metals. So we have already discussed that some metals are highly reactive, some metals are moderately reactive, and some metals are less reactive, and depending upon that, so the metallurgical processes are different. Now, what are the main steps that are involved in the metallurgy? So it involves a concentration of ore, conversion of concentrated ore to oxide, reduction of oxide to metal, and at the end refining of metal. So as we have already discussed that the elements have different reactivity. So this is what called reactivity series. Your lithium, okay, to mercury, so they usually exist in sulfide, carbonate, oxide or chloride form, whereas your silver, gold, platinum, they usually exist, right? This mostly exist in free state or native state. Now your lithium to aluminium, so these are the most reactive element, so they react vigorously with the reagent, right? And from zinc to lead, so these are moderately reactive, that means the reaction of this element or metal with the reagent is less vigorous, okay, and the reactivity of this copper and mercury, these are less reactive, and gold, silver and your platinum, so these are least reactive, and for that reason they usually exist in free state or native state. Now depending upon the reactivity, okay, of these elements, so these are grouped, and each group will extract it in the same way like ore, okay. So first what we do is the concentration. Now concentration is removal of gangue, that we are going to discuss in detail in next video, okay. First we'll do the concentration. Now depending upon the reactivity of this metal, like metal of high reactivity, so what we do is we usually do the electrolysis of the molten ore, okay, and you will get the pure metal. Now if the metal is in the middle of the reactivity series or the metal of medium reactivity, so they usually exist in carbonate, sulfide or hydrated form. What we do is, if it is in carbonate or hydrated form, we do the calcination, and if it is in the sulfide form, so we do the roasting, okay. Then on doing this, both carbonate, sulfide or hydrated ore will convert to oxide, and we remove the oxygen, okay, from that oxide. This is what called reduction, and after reduction and after getting crude metal, okay, we do the purification. And if the metal is lying at the low reactivity series, okay, they usually exist in sulfide ore. So what we do is we do the direct heating in presence of oxygen. Then on heating only we'll get your metal, crude metal, which is then refined at the end, okay. Now so I've already told you, so depending upon the reactivity or the position of this element in the reactivity series, so they are extracted in different ways. So more we are going to discuss in next video.